So students, today we will learn how to draw the molecular orbital picture for H2 plus and H2. So as I have already told you that for drawing the MO picture, first we have to look at the atoms involved in the formation of the molecule. So here you have first one is H2 plus. So you have one hydrogen atom and one H plus ion. These two combined to form the H2 plus. In hydrogen, you know you have one electron, and H plus there will be no electron, so it will be 0. So we have to write the electronic configuration of hydrogen. Electronic configuration of hydrogen, and that is 1s1. Now we will draw the MO picture for H2 plus. So in this side there will be one atomic orbital. This side you have one atomic orbital. This one is hydrogen atomic orbital, and right side is also H plus atomic orbital. These two will now combine to give the molecular orbital. So first there are two atomic orbitals, so they will combine to give rise to two molecular orbitals that I have already told you that. So these two are the molecular orbitals, and in here you have to write molecular orbitals of H2 plus. What are they? They are, this one is sigma and this one is sigma star. What is sigma? Sigma is the bonding molecular orbital. So sigma is equal to, what is that? Bonding MO, and sigma star is equal to anti bonding MO. Okay, so as they are formed by using the 1s orbital of hydrogen and H plus, so we will, in the subscript we will write 1s. So sigma 1s and sigma star 1s, and in this side we will show the energy axis always. This you have to show always. After that we will put the electrons in the molecular orbital. Here in hydrogen, as you have seen already, you have one electron, and here there is no electron. So the number of electrons in this bonding orbital will be only 1. Now how we are going to determine the bond order? Bond order for H2 plus, we will write the general formula. Bond order is equal to number of electron in bonding orbital minus number of electron in antibonding orbital divided by 2. So here it will be is equal to number of electron in bonding orbital, this is 1, so you have 1 minus no electron in the antibonding orbital, so it is 0, divided by 2, so it will be half is equal to 0.5. So now you know how to determine the bond order for any molecule. Now I'll do it for H2. So in H2 you have two hydrogen atoms, and both will have one electron in 1s orbital. Now drawing the MO. So first draw these atomic orbitals here. Hydrogen atomic orbital. This is also hydrogen atomic orbital and these are 1s orbitals, so denote that. Then you combine these two to give the bonding and antibonding molecular orbitals. Here are this. Then you put the electrons in 1s 1 and here is also 1. Then you show the energy axis here. Now this is your MO of H2. Now you have to put the electrons in the molecular orbital. So in one molecular orbital you can have maximum 2 electrons. So you have 1 electron from here and you have 1 electron from here. So this MO is, and this is what? This was the sigma 1s orbital and this is sigma star 1s orbital. This is the bonding orbital and this is the anti-bonding orbital, and you have now in the bonding orbital you have 2 electrons and in the anti-bonding orbital you don't have any electrons. So what will be the bond order? So bond order is equal to, I am not writing the formula, number of electron in bonding orbital minus number of electron in the anti-bonding orbital divided by 2. So here you have in the bonding orbital you have 2 electrons, so I am writing here 2 minus no electron in the anti-bonding orbital, so this is 0. Now this divided by 2, so that means is equal to 1. So the bond order for hydrogen is 1. So what we have seen now, the bond order for H2 plus is 0.5 and for H2 this is 1. So as the bond order in H2 is more, so H2 will be more stable molecule.